So I'm Dr. Lutz Mary, Associate Professor in the Department of Computer Science and Engineering. The subject I'm going to take is, the subject code is CS8088. Subject is Wireless Ad Hoc Consent Network. So the core objective is to understand the transport layer and quality of service in wireless. So first we have to know the basics of wireless sensor network. So up to the point, the reliability and robustness have been ignored. The possible reason is wireless sensor network is low cost. It's not necessarily due to the redundant data, and also difficult but requires reliability, disaster recovery and military application, etc. The focus is for reliability, the reliable transport layer, low packet loss, and bidirectional reliability. So what are the challenges of wireless sensor network are limitations of sensor nodes, application specific requirements objectives, reliable transport, then flow control, congestion control, self-configuring network, energy awareness. The current scenario is on-stream reliability from sync to sensors. Reliability semantics are different. 100% on cost of scarce resources. PSFQ block of packets data. MOAP block of packets data. Garuda is the block of packets data. Pump slowly, fetch quickly. The PSFQ stands for pump slowly, fetch quickly. Three basic operations are pump, fetch and report. Alternate between multi-hub forwarding and low error rates and store and forward when error rates are high. Pump operation, if not duplicate and in order, time to live is not zero. Catch and schedule for forwarding at time t, and t lies between the values of minimum and maximum. So t is 1 to 1. So the value lies between 1 to 1. T min is 1, T max and T min is 1. So pre-fetch pump slowly, fetch quickly. Fetch mode is 3 2 1 2, 1 1 2 2. Last is 1 and 3. Recover will be having 2 2 2 2 3 3. So pre-fetch pump slowly, fetch quickly. So last 3 have to recover T minimum and T max. So it's used to provide feedback data of delivery status. To minimize the number of messages, the protocol is designed so that a report message travels back to the target node from the source node to the intermediate nodes. So the methodology used is piggybacking. And so when compared to previous results, scalable, reliable multicast, the simulation results shows that pump prefetch and sequence, there has a better performance in terms of error tolerance, communication overhead, and delivery latency. It is attributed to the similar simulation experiments. So quality of service in wireless sensor network. The wireless sensor network is composed of a set of distributed hardware constrained wireless devices in charge of monitoring targeted areas. The growing usage of wireless sensor in different scenarios makes the quality of service a paramount issue in wireless sensor application. Quality of service refers to the quality of information provided such as data accuracy, resolution and timeliness. So these are the key factors of quality of service. So wireless sensor networks are data centric. It's a broad concept of the traditional network. Its main focus is on the performance, low level performance due to delay. Jitter is the variation in the delay, and the throughput is optimal out of the network. So requirements is bandwidth, delay and delay jitter, the packet loss rate. So bandwidth should be more, then the bandwidth relay should be lesser, and the delay jitter should be lesser, and packet loss rate also should be low. So the quality of service in wireless sensor network, it's different from conventional network in the type of services it provides for. So these networks are essentially only move bits from one place to another. Some generic possibilities are event detection or reporting probability, event classification error, event detection delay, missing reports, approximation of accuracy, tracking accuracy. The criteria generally aim to improve delay, include the delay should be lesser, energy consumption also lesser, resilient, then the moving or the mobility should not affect the quality of service, the reachability should be more, and the packet losses should be lesser. Energy efficient protocol defined. So sensor net nodes are employed in remote locations with limited power capacity. Replacement of power sources is not easily possible. When an energy level of the node decreases, it may stop functioning and the communication between the node and base station ceases. The situation may arise when some nodes may not be able to communicate with each other. This is called partitioning. Scalability, whenever the size of the network increases, then it has to provide the quality of service. Wireless sensor, this is one of the important issue have to fulfill the quality of service. Since the network is spread over a large geographic area, the region is extended, the protocol should be scalable in terms of coverage and density of sensor networks. So self-configuration, so the conditions like node failure, link failure, mobility of the nodes, and node transition, state transition impose additional requirements on nodes and protocol design, which must be self-configuring and self-maintaining in the nature. The dynamic nature of the network increases the complexity in providing quality of service. Self-configuration, unbalanced traffic. The flow of traffic in sensor network is highly unbalanced. So most of the traffic flow, you can have thousands of sensor networks to the sync node and maybe lesser. QoS mechanism. So you have the redundancy in data, bulk of amount of data transmitted from the source to destination many times. So some mechanism is necessary for the data aggregation or data fusion. So redundant data transmission consumes the parameters are bandwidth, buffer space, and the processing capabilities. So energy management, the sensor node consists of a sensing unit, processing unit, a transceiver, and a power unit. So all these components are assembled into a small part which has limitations of. So sensors are the tiny devices. It will processing of power will be lesser, low transmission rate, and a limited power source. The unbalanced load on processing power and transmission data results in unbalanced in the energy level. So QoS provision mechanism must incorporate these factors into account. Heterogeneous traffic, the sensors for different sensing application have different features in terms of data transmission rate, so processing of the data and energy requirements. So the mix of the sensors monitoring pressure, humidity, temperature, etc. have different traffic characteristics which must be taken into account while providing QoS. The QoS support, so it uses asynchronous transformer ATM or such as inter-serve and differential services are not applicable to wireless sensor network. These are the things that is applicable to the traditional network. So the resource provisioning will not be there in that network. One of the important characteristics of wireless sensor network is bandwidth utilization. It's a critical energy management. Since sensors are tiny devices, it occupies less power. The energy consumption has to be eliminated in wireless sensor network. So issues such as scalability, data redundancy, self-configuration nature, link failure, and limited resources imposes. These are the challenges in designing QoS framework. So the possible questions are: explain about transport layer in wireless sensor networks. Discuss about quality of service in wireless sensor network.